Today we're going to discuss the measurement and interpretation of elasticities, and we're going to use the demand curve and the concepts that we learned in the last lecture to study elasticity. And I'm going to warn you up front that elasticity is probably one of the most difficult econ topics that we're going to go through. So if you go through this lecture and you find yourself totally lost, please feel free to contact me, call me on the phone, and we can discuss further, or send me an email and say, I really don't understand this. Can you maybe put up a little video explaining such and such a little bit more? But this is definitely one thing that students tend to have the most problems with, and it's really it's difficult because sometimes it doesn't seem very applicable to what we're talking about. So I'm going to work my hardest to try to convince you that it really is applicable. So some of the discussion topics, we'll go over 3 different types of elasticities: an own price elasticity, an income elasticity, a cross price elasticity. We'll talk about some of the general properties of elasticities, and again, hopefully by the end you'll understand the application of demand elasticities. So, more key concepts. Our own price elasticity is talking about a percent change in the quantity of beef or product for a given percent change in the price of that same product. So that's why we call it own price. So we're looking at if I increase the price of my product by a certain percent, what am I going to see as the change in quantity that I'm going to sell, or the quantity that will be demanded by the consumers for that percent change in price. So remember, those triangles stand for change. On income elasticity, your formula is looking at percent change in the quantity of beef or the quantity of a product for a given percent change in income. So if we see a percent change in the income of the consumers, how is that going to impact the quantity that they're going to demand of my product? Cross price elasticity looks at the percent change in the quantity of a product for a given percent change in the price of a different product. So what's going to happen here is we're going to go back to some of our demand shifters. And remember, we talked about prices of other goods. So on this one, we're going to look at what happens if I have goods that are substitutes, like my current example shows with chicken and beef. And if the price of chicken increases, what's that going to do to the quantity of beef that consumers would like to purchase? And then on the other side of that, we're going to look at what happens when we have complements, so goods that go together, like bread and butter, peanut butter, and jelly. First, we're going to look at the own price elasticity. The own price elasticity formula, in more simpler terms than from the previous slide, is the percent change in quantity over the percent change in price. And remember, this is all for the same good. So you can see that written out in words or with symbols: percent, triangle, Q. So percent change in quantity divided by the percent change in price equals the own price elasticity of demand. You will probably see own price elasticity shorthanded as OPE. I think that's where the book might do E with a sub O. So let's go ahead and take an example. And I decided to use a different type of way to draw things this time. I realize that me drawing with the mouse is not necessarily the most conducive for you understanding exactly what I'm drawing. So in this case, though, with formulas, it'll be a little different. So let's say we have a percent change in price of 3% and a percent change in quantity of 5%. What we're going to do is we're going to plug those numbers into our equation. So we'll have 0.05% change in quantity divided by 0.03, and that's going to equal our own price elasticity. So if we solve, you should get 1.67. And one thing to note about own price elasticity is because of the law of demand, what's going to happen is if there is an increase in price, so if we say this was a percent change in quantity, an increase of 3%, we're going to see a percent change in quantity as a decrease. And that's because of the law of demand. So if we increase prices, consumers aren't willing to buy as much. Which means that our 5% is actually negative. Which would also carry down to our answer. Own price elasticity will always be a negative. We'll always come up with a negative on own price elasticity because of the law of demand. So if we have our answer of the negative 1.67, what does that mean? Well, this chart is going to help tell you what that means. So what we're looking at is the elasticity coefficient means our answer. So in simple terms, that means negative 1.67. If that answer is greater than 1, and it's the absolute value because they will all be negative. Every single own price elasticity is negative. So if the absolute value is greater than 1, demand is said to be elastic. And that means that the percent change in quantity is greater than the percent change in price. If the own price elasticity coefficient is equal to 1, we say that's unitary elastic, and the percent change in quantity is the same as the percent change in price. If the elasticity coefficient is less than 1, so between 0 and 1, because remember we're not going negative since they're all negative, so between 0 and 1, demand is said to be inelastic, which means that the percent change in quantity is less than the percent change in price. So our answer of negative 1.67, if we take the absolute value of that then becomes 1.67, which is greater than 1, so the demand for the product that we were looking at is said to be elastic. Now what does that mean, Miss Shapp? Elastic, inelastic? That doesn't make any sense. Demand curves, when we drew them, I drew them pretty much most like the red line on this graph here. And I did almost a 45-degree angle. A lot of times when learning, it's best to draw the same shape or the same angle on the demand curve, and that 45 degrees is what I've discovered to be the easiest one to understand most of the concepts with. Well, but that's not true. They're not all 45-degree angles. Demand curves, every single one of those lines on this graph is what I would call a demand curve. We could label them all as demand curves. The difference is the elasticity of the curve, which is quite simply the angle or the degree to which the curve is downward sloping. This one up here is a completely inelastic demand curve. So a vertical line is seen as an inelastic demand curve. And one of the easiest ways to remember is if you put a straight line up top, it basically creates an eye. So if you look at the straight line, your vertical line, and then this bottom you've created an eye. That's inelastic. And a completely vertical one means that even if I continue to increase price, it's not going to change the quantity sold. The completely horizontal demand curve is the opposite of that, which is a elastic demand curve. So that would be completely elastic. And if we draw ourselves a line up here, you'll see, if I go this way, down, and use the bottom there, that I have created an E. So the completely horizontal is seen as an elastic demand curve. This blue one is more inelastic. It's more vertical than it is horizontal. And this green one is more elastic. So it's more horizontal than it is vertical. And again, if you draw lines at the top, it'll help you try to figure out if it's an I or an E. And that'll let you know elastic, inelastic. So again, perfectly inelastic is vertical. Perfectly elastic is horizontal. The blue line is a little more vertical than it is horizontal, so that would be inelastic. And the green line is more horizontal than it is vertical, so that would be elastic. Now that's great. Why are we learning this? Why do we need to know this stuff? So an elastic demand curve is shown on my graph here, and what we're looking at is we see price B to price A. So if we go from price B to price A, we're looking at a drop in price, and all we've done here is put a price line in and put the quantity line where it touches the demand curve. And what we notice is that a decrease in price brings about a large increase in the quantity demanded for an elastic product. So what this means is if you know the demand elasticity of a product that you sell in your store, you can see that if you drop the price a little bit, you will probably see a larger quantity of that product sold. Does that necessarily mean that you made more money? In this case, yes. Producer revenue increases since the percent change in price is less than the percent change in quantity. So the red box would be our revenue. So we calculate revenue by taking price times quantity. So you're calculating an area. So the red box would be our original revenue, and the green box would be the revenue after the price change. And you can see here that it's bigger, which signifies that we would be making more money. So some revenue implications. If you have an elastic product and you decrease the price, you'll see an increase in revenue. If you have an elastic product and you increase the price, you're going to see a decrease in revenue. And a way to think about elasticity and if the product is elastic or inelastic, and you really don't know unless you crunch some numbers. But the best way that I have found is most elastic products are not necessary for everyday life. As far as like if you think about a person needing or looking at new cars, if they have a car that already runs and the car companies increase their price a little bit, that person's going to wait. However, if they cut their price, that person might decide that that's a good deal and they're going to go buy the new car. A man who needs heart medication in order to survive, his choices are limited. So he either takes the medication, pays what the drug companies are asking for it, and takes the medication, or he dies. If they increase the price of that heart medication, he's still going to purchase it. Because he has to have it. So looking at the inelastic demand, a cut in price, or a decrease in price from PB to PA, brings about a smaller increase in quantity demanded. So you're still seeing an increase in quantity demanded because anytime you cut price, more people are going to be willing to purchase it. However, producer revenue actually was better before they decreased their price. It's a little harder to see on this graph than it is on the demand curve, or the elastic demand curve. The boxes are definitely different sizes. And this one's a little more difficult, so you'll kind of have to take my word for it. But producer revenue will decrease if you have an inelastic demand curve and you decrease your price. So inelastic, if we cut the price, we'll see a decrease in revenue. If we increase the price, we'll see an increase in revenue. Most agriculture products tend to be inelastic. And if we think about why, people need food to eat. People need food to survive. Here are some examples, and again, all of these numbers are negative, so we're looking at the absolute value of all these numbers right now. But beef, milk, wheat, rice, carrots, for the most part, are all inelastic, so they're all less than 1. So that's own price elasticity of demand. The next type of elasticity is what we call income elasticity. And your formula is the percent change in quantity over the percent change in income. So in this case, again, what we're looking at is we're trying to find what's going to happen to the quantity demanded of my product if the consumer's income changes. So this is something that has been fairly applicable to our current economic situation. Incomes all across the board are down, and producers and shops and stores have had to deal with looking at how much less quantity that consumers are buying. Let's do another example. So we have the percent change in quantity over the percent change in income. So if consumer income decreases, say by 4%, we'll say the quantity of ramen increases by 2%. So if consumer income decreases by 4%, the quantity of ramen noodles increases by 2%. So we're going to fill in our formula. So the percent change in quantity is going to be the ramen, which is our 2%. And the consumer income is going to be the 4%. If you're looking up at the screen and saying, "Ms. Shapiro missed something," you are correct. This decrease signifies that we need a negative sign in front of that 4%. then if you solve, you'll see that we end up with negative 0.5%. What does that mean? Great, we can calculate a number. The important part is to know what that number means. So this chart is a handy tool to help you interpret income elasticity. So if our income elasticity, so the number that you come up with, is greater than 1, we have a luxury and a normal good. If it's less than 1 but greater than 0, it's going to be a necessity and a normal good. And if it's less than 0, it's going to be an inferior good. So in this case, we're not looking at absolute value, we're looking at the number that we come up with. So the number that we came up with was a negative number, which means that it's less than 0 and an inferior good. And that should confirm what we know about ramen noodles. Ramen noodles are cheap, and when consumers mainly only eat them when they are forced to because of money issues. So this isn't, the goal here is not going to be to trick you and make Spam be a luxury good. I'm not going to do that. It will all make logical sense. So you should be able to already guess what your number is going to come up with. Maybe a difference between the luxury and the necessity, but hopefully you can at least classify it as a normal good. And know the difference between the normal and the inferior goods. Here's some examples of some income elasticities. So you'll see there's rice comes out negative, and we tend to see that as an inferior good. Fruit juice is greater than 1, so we'd see that as a luxury good, and most of the other items tend to be seen as just normal goods or necessity and normal goods. Let's look at this a different way now. So before I gave you the percent change in quantity and the percent change in income, and we calculated the income elasticity. Now what we're going to end up being able to do, though, is we're going to know the percent change in income, and we know the income elasticity for a good. So what we're going to have to do is work backwards to then see what impact that would have on the demand for chicken. So assume the government cuts taxes, thereby increasing disposable income by 5%. The income elasticity for chicken is 0.3645. So again, we're going to start with our formula. The percent change in quantity over the percent change in income equals the income elasticity. And we're going to fill in the numbers that we know. So we know the percent change in income is 5%, and it's an increase, so there's no negative sign. And we know that the income elasticity is 0.3645. What we don't know is the percent change in quantity. So that's what we end up having to figure out. So you should have written on your paper 0.3645 equals the percent change in the quantity of chicken divided by the percent change in income. And we can fill out the percent change in income as 0.05. And then working backwards, what we'll end up having is percent change in quantity over 0.05. And we want to get that percent change in quantity by itself. So in order to do that, we have to multiply both sides of our equation by 0.05. So if I multiply the percent change in the quantity of chicken over 0.05 times 0.05, what that's going to do is it's going to cancel out those 0.05s on the right side of my equation. On the other side of my equation, it's going to end up being 0.3654 times 0.05, which ends up being 0.018 or 1.8%. So what that means is if the government cuts taxes and they increase disposable income by 5%, I will see an increase in the demand for chicken of 1.8%. So I came up with 1.8. I need to know if that's a normal good or an inferior good. And you'll go back to the chart on the previous slide and see that chicken is a normal good. I'm not really concerned about the necessity and luxury. I'm really more concerned about normal versus inferior goods. The third type of elasticity is cross-price elasticity. So in this case, we're looking at the percent change in the quantity of one good versus the percent change in the price of another good. So I shorthand cross-price elasticity is CPE. And your formula is the percent change in the quantity of good A divided by the percent change in the price of good B. So if we say that there is an increase in the price of jelly by, let's see, 4%, we're going to see a decrease in the quantity of peanut butter by 7%. And I want to know the cross-price elasticity. So again, we're going to fill out our equation with numbers. So the percent change in the quantity of peanut butter is 7%. And we have a decrease, which means we need a negative sign. We have an increase in the price of jelly of 4%. So 0.07 divided by 0.04 means that cross-price elasticity is going to be negative 1.75. So this is the most basic way to use this formula. So as our first example, I gave you the percent change in price of one good and the percent change in quantity of another good. We plugged our numbers into the formula and calculated a cross-price elasticity. So great. Once again, we came up with a number. What does that mean? What does negative 1.75 tell us? Cross-price elasticity is probably one of the easiest to interpret, and again, it's something that will make sense. So I'm not going to try to trick you. This one should be logical. So negative 1.75 is a negative, which means that the two goods are complements. And as we went through the problem, hearing peanut butter and jelly together, you should have already thought that those goods were complements. So you should know that you're coming up with a negative number. If the cross-price elasticity comes out positive, the goods are substitutes. And if it comes out to 0, the good is classified as independent. Once again, we're going to use this in a different fashion. Instead of knowing the percent change in price and the percent change in quantity, I'm going to give you the cross-price elasticity and the percent change in price, and we're going to see what impact that's going to have on hamburger consumption. So in our example, the cross-price elasticity for hamburger demand with respect to the price of hamburger buns is equal to negative 0.60. So already we're looking at a negative, which means that we're dealing with complements. If the price of hamburger buns rises by 5%, what impact will that have on hamburger consumption? So again, we're using our equation of cross-price elasticity equals the percent change in quantity of one good divided by the percent change in the price of another good. And we're going to fill out the information. So we know cross-price elasticity, so we can plug that negative 0.6 into that spot, and we know the percent change in price is 5%, so we can put a 0.05 in that spot. So you'll have negative 0.06 equals the percent change in the quantity of hamburgers divided by 0.05. Once again, in order to get the percent change in quantity by itself, you need to multiply both sides of your equation by 0.05, and you'll end up with negative 0.03 or 3%. So if the price of hamburger buns increases by 5%, we're going to see the impact of hamburger consumption. People will demand less hamburgers because hamburger buns are more expensive, and those two go together. So the demand relationship between the two products is that they're complements. So there's a negative sign in the cross-price elasticity. That means that the two goods go together and are complements. Here are some things for you to think about and hopefully discuss on D2L. Which market is riskier for producers, elastic or inelastic? Which market would you start a business in? And which market is more apt to need government subsidies to stabilize producer incomes? This is a little review from the previous chapters. What causes a movement along the demand curve? Or what causes a change in quantity demanded? If you said price, you're following along nicely. What causes the demand curve to shift? If you thought to yourself or shouted out any one of those demand shifters, education, experience, prices of other goods, income, population, if you said any of those, once again, you are retaining information. Know how to interpret all three of the elasticities. So know how to utilize the formulas to come up with a percent change in quantity or the actual elasticity, own price, income, or cross-price elasticity, and then know what those answers mean. So it's not good enough just to be able to come up with an answer, you got to tell me what it means. Understand some revenue implications. So this is really the most applicable part of elasticities. It's being able to know if I increase my price, is that going to net me more money? Or am I going to lose money if I decrease my price? In Chapter 6, we're going to start talking about the supply curve. There will be a elasticity worksheet to do on D2L, and once again, feel free to contact me if you have any questions.